students, a very warm welcome to my channel Ritu Maths Classes. Today in this video we are going to learn about addition of complex numbers. Supposingly we have two complex numbers z1 and z2. I am taking the standard complex numbers. So z1 is equal to a plus iota b and z2 is equal to c plus iota d. Then how to add these two complex numbers? Let's see this process. I have put in the value of z1 as well as z2. Now, when we add these two complex numbers, the real part will get added into the real part. So it is a plus c plus imaginary part will get added to the corresponding imaginary part. So I can say iota is common, b plus d, which is again a complex number. So this thought gives us the next topic, properties of addition of complex numbers. The very first property is the closure law. As the name suggests, the closure law, closure, I am going to focus on this word. As the name suggests, it means when I add two complex numbers, the again sum is always a complex number. The sum of two complex numbers is again a complex number. Therefore, set of complex numbers is closed under addition. Is closed under addition. For example, आपके पास एक सेट है कॉम्प्लेक्स नंबर्स का, उसमें से आपने दो कॉम्प्लेक्स नंबर्स लिए z1 एंड z2. You added them both and the result is again a complex number. मतलब रिजल्ट आपको उसी सेट में से अवेलेबल हो गया, आपको कहीं बाहर से लेके नहीं आना पड़ा कोई नंबर. So it means the set is closed. आप उसके अंदर बड़े अच्छे से एडिशन कर सकते हो और रिजल्ट्स वहीं अवेलेबल होंगे. So that is why we say set of complex numbers is closed under addition. The second property is the commutative law. Supposingly, I have two complex numbers and I have added these two numbers. These were in general. Let me take it in particular for better understanding. I am going to take z1 as 2 plus 3 iota, any complex number, and z2 as 4 minus 5 iota, any other complex number. So if I add z1 and z2, real part will be added into real. 2 plus 4 is 6. And the imaginary will add into imaginary. Plus 3 iota minus 5 iota gives us minus 2 iota. But supposingly, I had gone for z2 plus z1. अगर मैंने ये सम इस तरह से लिया होता z2 plus z1 करके, तो क्या आया होता? z2 plus z1, 4 plus 2 is 6. Minus 5 iota plus 3 iota again gives me minus 2 iota. So therefore, I can say that z1 plus z2 is equal to z2 plus z1. You can term it as an example for verification. Therefore, the two complex numbers have commuted while addition. They have no problem in interchanging their spaces. It means the commutative law holds in the addition of two complex numbers. The next is the associative law. As you have been doing these laws in algebra of the real numbers also, in commutative law we generally take two numbers, but in associative law we take three numbers. So I am going to extend this example for associative law now. I have to take three complex numbers. I have taken z1, z2, and let's take z3 as 6 plus 8 iota. Supposingly, I tell my class to add all these three complex numbers. Some of the students might be going for z1 plus z2 plus 3. Means they will add z2 and z3 first of all and then add z1. What will be their result? Let's see. z1 as such plus Z2 plus Z3. So ये दो complex numbers पहले add होने हैं. I'm going to add the real parts of Z2 and Z3. 4 plus 6 is 10. Then added Z3 the complex part. Minus 5 plus 8 gives us 3 iota. Now I'm going to add Z1 into this. This is the value of Z1. So Z1 real part 2 and this real part 10. When added it gives me 12. Plus 3 iota plus 3 iota gives us plus 6 iota. But ये भी तो हो सकता है. Some of the students add Z1 and Z2 first of all, because I have told the students to add 3 complex numbers. So कुछ class ऐसे करेगी कि Z2 and Z3 पहले add कर लिया and then Z1 is added. But some students may have gone for कि जी चलो पहले Z1 and Z2 add करते हैं, फिर जो आएगा उसमें Z3 add करेंगे. Let's see उनका result क्या आता है. Z1 and Z2 added. 4 plus 2 is 6. Plus 3 iota minus 5 iota gives me minus 2 iota. Plus Z3. Now they will add the Z3 into it. Let's see the value of Z3. This is the value of Z3 when added into this. 6 plus 6, real part, is 12. Plus 8 iota minus 2 iota gives us plus 6 iota. So you can see 12 plus 6 iota is equal to 12 plus 6 iota. It means I can write down Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. Means if I have 3 complex numbers, it does not matter if I add the first 2 and then the third one, or I add the second and third and then the first number is added. Basically, in the process of the addition can be changed, but the order should not change. Z1, Z2, Z3. Here also the order is Z1, Z2, Z3. Let's continue with the next property, the existence of additive identity. Supposingly, I do have a complex number Z, a single complex number Z, so I am not referring it as Z1, simple complex number. Let it be Z. I want to add something, additive. I want to add something into it so that the result remains identical. Additive identity, as the name suggests, most of the properties are very easy to understand if you understand the name very well. Additive means I have to add something into the complex number Z such that it remains identical. So what should I add over here? All of you will be simply saying just add 0. But that complex number should be added into another complex number. So can I write this 0 as a complex number? Yes. Where 0 is equal to 0 plus 0 iota. It means I have got another complex number which I add into the given number and the result is still identical. No effect on result. Therefore, this 0, which is better known as 0 plus 0 iota, is the additive identity. You may get 1 mark questions for the additive identity. Find out the additive identity of Z. Maybe the Z is 2 plus 3 iota or 4 minus 5 iota, anything. So you will be simply writing down 0 plus 0 iota. 0 plus 0 iota is the additive identity of Z. Next, the existence of additive inverse. Again, as the name suggests, I want to add something into my complex number Z such that it is just vanished. It is getting its identity back. If the identity is 0, so I should get back 0. Now what to add in Z? अब मैं Z में क्या add करूँ कि ये 0 बन जाए, वापस अपनी identity पे पहुँच जाए. To get back the identity is known as the inverse. Okay. So what should I add? All of you will be saying just add its negative, because plus minus will be minus. Z minus Z will be 0. So I have added minus of Z over here. This implies minus of Z is the additive inverse of Z. Means if you get a question, let me give you an example. Find the additive identity and additive inverse of 2 plus 3 iota. So what should be your solution? Let Z is equal to 2 plus 3 iota. I have labeled the complex number. So additive identity is equal to 0 plus 0 iota. Reason, because 2 plus 3 iota when added with 0 plus 0 iota gives you the identical result. When it gives the identical result means this is the additive identity. And additive inverse. Now you know that additive inverse is nothing else but the negative of the complex number. Z अगर complex है तो minus Z उसकी additive identity है, inverse है. So इसी तरह से 2 plus 3 iota is the number. So additive inverse will be minus of 2 plus 3 iota. That is, I can say minus 2 minus 3 iota. Let's justify by giving the reason. 2 plus 3 iota is the original number given in the question. I have to add the additive inverse into it. I have added the inverse. Now let's see what happens. 2 plus minus 2. Real part is 0. Plus 3 iota minus 3 iota is again 0 iota. So I have got back the identity. When you get back the identity, that is the additive inverse. Now very easily these properties can be incorporated in the questions. Basically these are for understanding and for application in questions.